The immense Sahara Desert is the second largest in the world. The largest is Antarctica. Originating in deserts, it is common that yellow clouds of sand are whisked up and carried all over the world. Prevailing northerly winds carry the sand clouds thousands of miles, sometimes reaching over the Alps and falling on unsuspecting countries in northern Europe.
What does all that sand do?
The sands can change the weather and affect long-term climates all over the world. Warm desert air currents and wind sweep the sandy dust up into the atmosphere. The sand forms gigantic dust carpets, some the size of Spain. Drifting off the west coast of Africa, some sandstorms journey across the Atlantic Ocean, towards the Caribbean and Brazil. Some of the sand ends up falling on the Amazon rainforest. Surprisingly, the sand provides the flora with a valuable nutrient-rich shower. The sand contains minerals the ecosystem needs, such as calcium, phosphorus, and potassium. Since the forest floor does not provide many of these elements, many mosses and different types of orchids have evolved rootless, growing high in the trees. They extract nutrients from the air around them. The Saharan sands can help the forest survive through this regular fertilization.
So the traveling sands can help in some places. Is it bad for other places?
Yes. A regular sandstorm that begins in spring in Mongolia often pesters the residents of Beijing. Sometimes over 300,000 tons of sand rains down. The problem seems to be getting worse, and large portions of the countryside are ruined by the desert sands. Intense farming methods and clear felling of trees for industrialization have contributed to the decline. China loses about 2,500 square kilometers every year to desertification. Desertification is the gradual change of habitable land to desert. Once formed, deserts can only support limited plant and animal life. China is not the only country facing the problems of desertification. Strong winds that whip up sand and dust particles have been intensifying all over the world. More sand is finding its way into the atmosphere than ever before. Researchers fear that the production of dust from the world's arid regions has increased 33%. Water molecules attach themselves to this mineral dust, aiding cloud formation.
Do these sands affect anything else?
Scientists think that sands may also affect hurricane development. Over the past few decades, the number of Category 4 and Category 5 strength storms has nearly doubled. Often forming in the Atlantic Ocean, the Caribbean, and the Gulf of Mexico, the United States gets the brunt of many of these weather events. Atmospheric researchers have concluded that between 1/3 and 1/2 of the dust transported from the Sahara moves on a trade wind jet stream towards Florida. The researchers are looking for a link between the sand content in the atmosphere and the area of the atmosphere where the probability is most favorable in regard to hurricane development. The Falcon is a research aircraft that flies into Morocco to study sandstorms in the Sahara Desert. Atmospheric researchers, geologists, and mineralogists must test all of the equipment before their flight to ensure that everything goes smoothly.
What equipment do they use to measure the storms?
There are lasers mounted on both wings and on the fuselage. The Falcon's specialty is its ability to conduct research in the troposphere at an altitude of over 12 kilometers. The scientists use the lasers to measure the exact mass, height, and width of a sand stream. LiDAR lasers work on a simple principle. They measure particles using reflected light. Every 30 milliseconds, the laser fires short impulses in duration of 10 nanoseconds. As it is fired into the atmosphere, it comes in contact with sand particles. The light is then reflected back to a large telescope. A decoder measures the amounts of light returning. If the light returning is high, there are a great deal of particles in the air. The fewer the particles present, the less light that will be reflected back. The distance of each particle is measured by the amount of time it takes the light to return. The scientists are evaluating a large segment of airspace between the altitudes of 400 meters and 60 kilometers above the desert. They must work quickly because summer is coming and the lasers will not work as well in an environment with scorching temperatures. A team of scientists is preparing an additional airplane. This small turboprop plane is equipped with a photometer.
What does a photometer do?
It measures how much sunlight passes through sand clouds by splitting the rays of sunlight into their basic components. This will tell them how much sunlight is getting through, how much is being reflected, and how much is trapped in the sand clouds. Meanwhile, the Falcon is preparing to take off on a course set by ground control, following a pattern set by the ground-based laser beams and the latest satellite reports on the dust cloud's movement. The data from the Falcon supplements the measurements taken from the ground. While the ground-based lasers run vertically into the sky, the Falcon's lasers run horizontally into the clouds, creating a more complete data picture. The turboprop plane flies as low as possible, where the other instruments are unable to measure how much sunlight comes through the dust cloud. These three methods of collecting data are ideal solutions for the scientists. Each method complementing the other, all measuring the same event at the same time in hopes of unraveling the secret of the airborne desert.
What kind of satellite is that?
That is a weather satellite, NASA's Calypso, the Cloud Aerosol LiDAR and Infrared Pathfinder Satellite Observation Satellite. It researches the relationship that clouds, atmospheric aerosols, and airborne particles have with Earth's weather, climate, and air quality. It has an active LiDAR, a passive infrared imaging radiometer, and a visible wide-field camera. Orbiting at a height of 800 kilometers, it uses pinpoint accuracy to plot the course of Saharan sand moving over 5,000 kilometers into the hurricane zone.
Have the scientists found anything?
Yes, it appears that the dust cloud is consistently 5 kilometers thick over the desert, and the top of the cloud is completely flat. The Atlas Mountains have acted as a ramp for the cloud to push up and off over the Atlantic Ocean. The data also implies that the more compact the cloud, the further it can travel. Scientists have determined that the dust particles are relatively large. They aren't sure if sunlight can pass through the dust cloud. At 2 to 3 microns, or 2 to 3 thousandths of a millimeter, they are large compared to other atmospheric particles. As a basis for comparison, this mosquito is 20 millimeters long, and the sand particle on its back is 4 to 5 microns in diameter. At this size, scientists are concerned that the particles are absorbing a lot of energy from the sun. The LiDAR pulses also show that the formation of clouds is greatly increased by the role the particles play in their formation. In turn, clouds reflect the sunlight, cooling the desert. They were surprised to find the existence of ice particles in higher altitudes above the cloud formations. There are indications that snow and rain are present, but evaporate before reaching the ground.
So the sand makes ice form in clouds?
Yes, they act as condensation seeds. As tiny water droplets attach themselves, vapor droplets form. This is how cooling clouds come into existence. However, they have learned that the dust consists of particles of varying properties, some of which store the sun's energy faster and to a greater extent than others. Another team of experts in the field of environmental mineralogy are in Morocco, to the south, near the Algerian border. They are using a complex dust-collecting station that filters sand particles from the air and sorts them by their different sizes. Their goal is to build an accurate picture of the minerals present in the sand. They found minerals that contain iron. These minerals are very good at absorbing light. The more particles present, the less light reaches the ground. The results show in some places the atmosphere is warmer and the ground is cooler. To decipher which particles tend to attract water, they are artificially humidified. Researchers observe which ones swell up the most when they come in contact with the water vapor. The particles from the dust collector are sampled on layered copper plates and further analyzed under a microscope. The different minerals vary in color and therefore absorb light from different wavelengths. Darker particles trap more sunlight, while lighter colored particles permit more light to pass through. Scientists are able to produce a more detailed chemical analysis of the particles using an electron microscope. It scans the surface of the particles with a powerful beam of electrons, creating a magnification of up to 1/1,000,000th of a millimeter.
Wow, that must be a powerful microscope. What did they find?
The team has hundreds of samples to process, all from the Sahara. Early results show that calcium seems most common, and gypsum, better known as plaster, and silicates. The measurements taken by the lasers confirm that a high proportion of the sun's rays are being deflected away from the Earth due to the high calcium content of the dust cloud. This means the desert sands far below are being cooled. To find out which particles promote the formation of water vapor clouds, a cooling element is added to the microscope. The vapor turns into ice, thus becoming more visible. Ice seeding research is still new, but we know that the physical structure of the particle is important. Ice forms more readily on particles with many different surfaces. Ice also forms easily on particles high in silicate. Most of the particles of the Sahara Desert have these characteristics.
So, this dust is making the deserts cooler and the oceans warmer?
Yes, and more clouds, more rain, and less vaporization is the result of a warming of air masses over the ocean. Relative to their finds and recent history, hurricanes gather their energy from the vertical convection of water vapor. Less vapor means less convection, resulting in a calmer atmosphere. According to this logic, they believe that the dust clouds of the Sahara could actually be interrupting the formation of hurricanes.
These scientists have very challenging jobs.
Yes, they do. A career as an atmospheric scientist involves studying physical characteristics, motions, and processes of the atmosphere, and the way in which these factors affect the rest of our environment. Many meteorologists find their career paths leading to the National Oceanic and Atmospheric Administration and the Armed Forces. Other meteorologists and ecology experts conduct research at the university level. With the help of ecologists and atmospheric scientists, it has become evident that even areas like the Saharan Desert, with uninviting and inhospitable conditions, can positively affect and help sustain life over extensive regions at distant parts of the globe.